As the 052D's upgrades reach the ceiling of its platform potential, are we witnessing the ultimate evolution of a legendary destroyer family while hearing the thumping heartbeat of a new generation of warships approaching? As the dawn of 2026 cast its first light upon the azure seas, the People's Navy welcomed the official debut of yet another deeply upgraded Type 052D destroyer. This new vessel is no mere replica. It has undergone meticulous refinement across multiple dimensions, stealth details, electronic warfare systems, data link integration, making it better suited for the demands of intelligent, system-based naval warfare in the new era. At present, 32 Type 052D destroyers sail the oceans. This staggering number itself stands as a silent declaration of a nation's industrial prowess and strategic resolve. Yet among military enthusiasts, reactions blend pride with heightened expectations. They cheer the rapid production pace while eagerly anticipating the emergence of a fundamentally new, future-oriented universal destroyer designed from the ground up. This happy dilemma may be uniquely Chinese. Rooted in the dazzling leap forward of China's shipbuilding industry over the past decade, it reveals that the cutting-edge mainstays, once looked up to now appear ripe for further optimization. This contradictory mindset precisely highlights the strategic flexibility and iterative capability China possesses, qualities envied by its rivals. By contrast, even the formidable U.S. Navy, constrained by its domestic shipbuilding industry's decline and high costs, often resorts to patching up Cold War-era legacies rather than rapidly and thoroughly innovating platforms to meet rapidly evolving threats. Rewinding to the inception of the Type 052D destroyer, its design philosophy was clear and pragmatic. Within a short time frame, integrate the most reliable and mature technologies available to create a regional air defense destroyer with balanced performance and mass production capability. This approach aimed to rapidly fill combat capability gaps and establish a credible deterrent. Whether it was the iconic HLJ-G346 active phased array radar or the pioneering dual-temperature vertical launch system, every feature was centered on the core objective of rapid combat readiness. History has proven this goal was fully achieved, with early 052D vessels holding their own against contemporary international counterparts. However, as a senior designer once candidly remarked, any equipment begins to lag behind cutting-edge technology the moment its design is finalized. We have gradually recognized that constrained by the objective conditions and cognitive boundaries of its era, the Type 052D inherently possesses limitations in platform redundancy, energy distribution architecture, and multi-mission scalability. Even subsequent upgraded variants, through hull lengthening, close-in weapon system enhancements, and optimized aviation support facilities, significantly bolstered anti-submarine and short-range defense capabilities. Yet these modifications essentially represent refined upgrades within the original framework. The most closely watched and enigmatic enhancements center on radar and electronics. Two conspicuous external changes offer clues: the distinctive Fleischwater-style new meter-wave surveillance radar replacing the older Type 517A, and subtle alterations to the main array's appearance, alongside iterations of the rear-end processing system. Although specific performance parameters remain shrouded in secrecy, China's breakthroughs in anti-stealth detection and ultra-low altitude blind spot compensation technologies suggest these upgrades primarily target countering stealth aircraft and saturation sea skimming attacks, striving to minimize battlefield awareness blind spots. Other systems like communications, electronic countermeasures, and command and control have undoubtedly undergone quiet yet profound evolution. It can be said that the latest batch of Type 052D destroyers has achieved a generational leap in overall combat effectiveness compared to earlier models. Behind the official reports detailing multiple system upgrades lies a tangible surge in combat capability. However, a growing consensus holds that after multiple rounds of optimization, the potential of this excellent platform is nearing its physical and design limits. This is by no means to assert that the Type 052D will cease to evolve. Future upgrade paths will increasingly focus on enhancing its soft capabilities, for instance, upgrading the rear-end compatibility of its vertical launch system to enable the deployment of more new variants, including future land attack, anti-ship, and anti-missile missiles, continuously improving its situational awareness and coordinated engagement capabilities through radar software algorithm updates and enhanced data fusion capabilities, and by installing more intelligent combat management systems to boost automation and decision-making speed. Such internal enhancements can significantly revitalize the vessel's capabilities. However, certain constraints rooted in the platform's original design cannot be fully resolved through retroactive upgrades. This is precisely why military enthusiasts eagerly anticipate entirely new platforms. While designers certainly reserve upgrade space, this capacity is not infinite. Helicopter operations exemplify this challenge. Despite the extended deck of the Type 052DL, its efficiency and safety in operating next-generation anti-submarine helicopters still lag behind platforms specifically optimized for large helicopters. Against increasingly potent and stealthier adversaries' underwater forces, anti-submarine aviation capabilities are critical to survival. Significantly altering the hull form to accommodate an extended deck would compromise the vessel's stability, reduce hydrodynamic efficiency, and degrade stealth characteristics, a trade-off that outweighs the benefits. An even more fundamental constraint lies in the propulsion and energy architecture. The mechanical transmission system used in the Type 052D profoundly dictates the ship's internal compartment layout and power distribution. In contrast, the integrated full electric propulsion system, representing the future direction, offers complete liberation from these constraints. Not only does it deliver superior stealth performance, but more critically, it provides unprecedented levels of abundant, flexible, and high-quality electrical power. In the future, whether it's the growing power demands of next-generation large-aperture phased array radars, high-energy laser weapons, and electromagnetic railguns, or the escalating computational and cooling requirements, all necessitate a robust electrical grid as their foundation. The layout freedom afforded by all-electric propulsion further optimizes a vessel's survivability and enhances damage tolerance. Therefore, a warship designed from the conceptual stage around new principles, all-electric propulsion, integrated masts, and modular design, is the definitive solution for future high-intensity naval warfare. Regarding this imminent new generation multi-purpose destroyer, rational online speculation has already sketched its general outline. It will inevitably be larger than the Type 052D to accommodate more advanced equipment and provide superior seaworthiness and endurance. However, it will likely avoid repeating the mistakes of the 10,000-ton Type 055 destroyer to prevent mission overlap and excessive costs. A reasonable tonnage increase of several thousand tons will yield more spacious hull accommodations, while the number of vertical launch cells may not surge dramatically, likely remaining within the 80-96 range. Key advancements lie in their depth, caliber compatibility, and the sophistication of the ammunition supply system. Crucially, this design will accommodate future hypersonic anti-ship, land attack missiles. Full electric propulsion will grant superior endurance and global deployment capability. Radar systems are expected to integrate advanced technologies, like dual-band operation, digital arrays, and smart skins, matching or surpassing the latest international standards in detection range, precision, multi-target processing, and anti-jamming capabilities. The close-in defense system will likely feature a composite defense comprising compact laser weapons, electromagnetic railguns, and conventional rapid-fire guns. Following the Chinese Navy's steady tradition of incremental development, technology validation, and mature mass production, the first batch of new destroyers will likely be built in limited numbers for final optimization through rigorous testing. In the more distant future, once full electric propulsion technology matures completely, a scaled-up, more capable Type 055 variant may already be on the blueprint. Thus, the ongoing refinement of the Type 052D and the imminent arrival of the next-generation destroyer do not represent mutually exclusive paths. Rather, they form a harmonious duality. In the Chinese Navy's equipment development, one of both continuity and leapfrogging. On one hand, existing mainstay platforms undergo extreme optimization to ensure sustained combat readiness. On the other, a new strategic layout for the next 3 decades is being established to secure long-term advantages. This rational, pragmatic, and visionary development rhythm embodies the measured strides of a naval power evolving into a naval superpower. As new combat capabilities emerge and interweave with deeply refined existing forces to form an integrated network, the People's Navy's voyage into the deep blue will become more resolute and unstoppable.